Okay, so now I'm recording already, yeah? I'm recording. Okay, so capacitance and capacitor in series and parallel. Okay, so we can connect capacitor in series. We can also connect capacitor in parallel. And also, sometimes we can connect capacitor in both series and parallel combo. So there are arrangement of capacitor, yeah, in series and parallel come together. So how to find, let's say, the total capacitance of all the capacitor in series and parallel. So that's our focus today, yeah. And we will also try out some tutorial questions, yeah, to enhance our understanding. Okay, so first of all, we start with capacitor in series. Yeah, we want to find the effective capacitance of capacitor. Effective capacitor means total capacitance lah. Yeah, total capacitance. And also in parallel. These are the formulas. Yeah, these are the formula how to calculate the total capacitance. Okay, so how actually, yeah, the question is how we actually derive these two formula. How we come to a conclusion to these two formula. So that is what we're going to investigate today. Now, let's look at capacitor in series. Yeah. So yeah, if capacitor in series, the charge is the same. Potential difference is total up altogether V1 plus VB2 plus V3, and effective capacitor is 1 over C. Why is it like that? Yeah. So maybe I should explain over here. Of course, in previous video, previous years, I already made a video about this, but I just fulfill my job for this year, so I teach again. Yeah, okay, no problem. So this one, yeah, it's capacitor in series. Let me just just write it over here. Capacitor in series. Okay, let's make it bigger. Where the best one should be 20. Okay, that be okay already. Capacitor in series. So yeah, this is a capacitor in series. Let me draw it better nicely. Capacitor in series. This is the battery. Okay, so we have a capacitor, C1, C1, C2, and C3. Okay, and then this is the battery. Total voltage. Okay, class. So how do we start? First of all, battery is positive, negative. Terminal positive and negative. And then the capacitor, they are uncharged. They are uncharged, neutral. No positive, no negative. But then, because once they connect to the battery, then this positive terminal start to attract electron. This positive terminal start to attract electron from the left plate over here. The left plate over here. Put it as a green plate. Yeah. It attract electron from there, from the green plate. So what happened is this green plate loses electron. It loses electron. When it loses electron, it become positive charge. So I can put it like this. So it become let's say positive Q. Yeah. Let's say it loses Q coulomb of electron. So this plate become positive charge because it loses electron. Okay. Now this green plate will also, once it got the positive charge, it will start to attract electron from this plate also. From this plate. Okay. This green plate will start to attract from this green plate of the C2 capacitor, the second capacitor. attract electron. You attract electron. Okay, and it will start to this electron will deposit on this plate. Deposit on the blue plate. Okay, how much electron is attracted? How much electron is attracted? So the amount of electron attracted from the second capacitor is the same amount of charge for the first capacitor. So this this green plate for C1, it gain positive Q coulomb. So it also attract Q coulomb. Yeah, so attract Q coulomb from the green plate of capacitor 2. So it attract Q coulomb of electron and deposit on the blue plate. So this green plate here for the second capacitor loses electron also. It loses Q coulomb of electron. So it also gain the same charge, positive Q also. Okay, and this positive Q coulomb has this Q coulomb of electron deposit on the blue plate. So the blue plate gain all the Q coulomb of electron, loses by the second capacitor, deposit at the blue plate. So this blue plate gain Q coulomb of electron. So it become negative Q. Understand? The Q coulomb of charge from second capacitor come out and deposit at the blue plate here. So this one positive Q, this one become negative Q. Understand? So the process continue for the third capacitor. So this plate become positive Q. It will also attract electron from the third capacitor, the green plate here, and deposit over here, blue plate here. Understand? It attract electron. So how much electron is attracted? Q coulomb also. So the green plate of third capacitor loses Q coulomb, so it becomes positive Q charge. And then this blue plate of second capacitor gain Q coulomb of electron, so it becomes negative Q. Understand? So and then the process continue. This green plate of third capacitor attract Q coulomb of electron from the negative terminal of battery. So electron move from negative terminal, go to the blue plate of third capacitor. The blue plate of third capacitor deposit at the blue plate here. So how much electron is attracted? Q coulomb also. Q coulomb. So it become this blue plate gain electron, gain Q coulomb of electron. So become negative Q because it gain electron, become negative charge. Can you see what's happening? So this results in all capacitor have the same charge. All capacitor have the same charge. Charges on all three capacitors are the same. Q equal to Q1 equal to Q2, Q equal to Q3. So I can say that Q total equal to Q1 equal to Q2 equal to Q3 equal to Q. All of them have the same charge. Okay? All of them have the same charge. Actually, class, charge is equivalent to current. You know, later in chapter 3, when you're going to learn about current, in the next chapter, you're going to learn about this thing, current, which is I, current. Current is the rate of flow of charge, dq over dt. Rate of flow of charge. Let me write it down. Rate of flow of charge. Charge that flows. Charge that flow in the circuit. So what charge is flowing in the circuit? Oh, somebody is coming in. Somebody is coming in. Okay. Admit all. Okay. Yeah. So, rate of flow of charge. Of course, current is a flow of positive charge. Yeah, flow of positive charge. Yeah, positive charge. But the flow of positive charge actually is because of flow of electron. Yeah, it's actually we can say current is like, it's caused by the flow of current is caused by flow of electron actually. Yeah, electron is a negative charge. Yeah, of course. So if you look at here, yeah, so got electron flowing. Electron flowing. All these are current. You understand? All these are current. Current is the opposite way lah, because we consider current as the flow of positive charge. Yeah, flow of positive charge. So this flow of, current is the rate of flow of charge. So the charge that flows, the electron charge that flows, actually is the current flow, And we remember that we learned about series and parallel resistor. Last time we also learned about series and parallel, but resistor, not capacitor. We learned series and parallel resistor. Remember, class? Remember? We have R1, R2, R3. Okay. So in this resistor, in the circuit, we have current flow. Current always flow from where? From positive. Current always flow from positive go to negative. Current always flow from positive go to negative. So actually, if electron, of course, is opposite direction lah. If electron is opposite the current. Can you see that, class? Yeah. So last time we learned about current flow in a series resistor. Yeah, this is a series resistor. I can write it like right here. This is series resistors. So I want to ask you, what is the current that flow through R1? What is the current that flow through R2? What is the current that flow through R3? What's the current? Do the current same or different? The current that flow through R1, the current that flow through R2, the current that flow through R3. Same or different current? Same, isn't it, class? Remember what we learned before? The I total, this is the I total, is equal to I1, current passes through R1, current passes through R2, and current passes through R3. Put as I current. Because why? Because series resistor is like only one way route. One way only. One way. So the current can only go one way. The current can only go one way. So all resistors receive the same current. All resistors receive the same current. So current is like charge. Charge is like current. Charge is like current. Yeah, because current is rate of flow of charge. That's why all these capacitors have the same charge. It's like all resistors have the same current. Understand, class? Want to see your hand? Do you understand? Okay. Good. Thank you. So that means charge is like current. Yeah. Last time we learned about series resistor. All resistors have the same current because only one way. Satu jalan saja, one way. So all current is the same. So this one, the charge or electron flow is also like current flow. Yeah. So all capacitors have the same charge. Q1 equal to Q2 equal to Q3. This is like current. Okay. So put it this one somewhere. Oh, sorry, excuse me. So let me see, this is the thing happening. I don't like. Wait. Let me open it again. Okay. Yeah, now better. Yeah, because technical problem. Yeah, technical problem. Okay, so group this. Okay, put it somewhere. Yeah. So now let's move on. Yeah, let's move on. So all have the same charge. Okay, for capacitor in series. Okay, let me. Okay, so capacitor in series. Now, how about voltage? Okay, I want to rub off this one. Okay, how about voltage? Voltage. Potential difference. So same thing like before. We also last time we also learned the same thing. Yeah, same thing like resistor R1, R2, R3. So this is the V total. V total. So we also learn the same thing. We also learn the same thing. So for series resistor, to find the V total is V1 equal V1 plus V2 plus V3. Yeah, same. So for series resistor, we V1 plus V2 plus V3. So same goes to capacitor in series. We also use the same thing. Yeah. So we know that across the across the capacitor 1 is V1, across capacitor 2 is V2, across capacitor 3 is V3. So we can put it V total equal to V1 plus V2 plus V3. Same like the series resistor, or plus plus plus. Series resistor. So capacitor in series also plus plus plus. It's like something like this. Okay, maybe I have this voltage. Maybe I put it as example. This total voltage is 10 volt. 10 volt. 10 volt means what? It means negative terminal has 0 volt. Positive terminal has 10 volt. So 10 minus 0 is 10 volt difference. Potential difference is 10 minus 0 equal to 10. Okay? So all along around this negative terminal, all along the wire here, all 0 volt. 0 volt. And then around this wire, all 10 volt, 10 volt, 10 volt. So 10 volt, 10 volt, and 10 volt. Understand? All around here is 10 volt. So across capacitor 1, so this the green plate here is also 10 volt. Okay, the green plate here is 10 volt, but going across C1, maybe it dropped to 8 volt. It dropped to 8 volt. And then this one is 8 volt, and then this plate also 8 volt, and then it dropped going across C2, it dropped to maybe let me see, maybe 5 volt. From 8 volt drop to 5 volt. And then this plate over here also share 5 volt, and then from 5 volt it dropped to 0 volt. Do you see what's happening? Let me write nicely for you to see. So okay, so V1 is 10 minus 8, which is how many volt? How many volt plus? 2 volt. And then V2 is 8 minus 5, which is how many volt? 3 volt. And what is the V3 class? V3, 5 minus 0 is 5 volt. So that means this is like, the total voltage, the voltage across the whole thing, from the green plate to the blue plate of last capacitor, across it is 10 minus 0 is 10 volt. 10 volt, 10 volt. Yeah, across the whole thing actually is 10 volt. But going across the capacitor, the potential drop. Yeah, it drop 3 times. So for capacitor 1 drop 2 volt, capacitor 2 drop 3 volt and capacitor 3 drop 5 volt. They're different because of their capacitance. Okay, so it's like, you know, 10 volt equal to, you know, 2 plus 3 plus 5 volt. Okay, so it's plus 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 together. Yeah, that's what happened lah. Understand, class? You understand? Good, thank you. Okay, so now move on. Yeah, so we have two relationship ready about charge and voltage. We have investigated. So now how about capacitance? So last time we learned about capacitance. What is the capacitance? C equal to Q over V. C equal to Q over V. So C equal to Q over V. That's the formula that we learned. C equal to Q over V. Now, so V will be equal to Q over C. Correct not, class? We can put it this way lah. Q equal to CV also. You see? C is charge over voltage. So V multiplied above, we got Q equal to CV. Q with CV. And then we can also change C with V. So V equal to Q over C. So we get, this is the formula that we're going to use. Okay, we're going to use. So we start with this formula. V for series capacitor. We start with V total equal to V1 plus V2 plus V3. We start with that formula. So we, okay. So we start with this formula. V total is, what is all this? So excuse me. Okay, yeah. So V total is Q total over C total. Let me derive it. So this is Q total over C total. If V1 is Q1 over C1, Q1 over C1, and then V2 is Q2 over C2, Q2 over C2, Q2 over C2, and plus V3 is Q3 over C3, Q3 over C3. And then, because all the Q is the same, isn't it, class? All the Q is the same. So that means we can factor out all the Q as a single, because they have the same charge. Capacitor in series, they have the same charge. It's like all of them have the same current. So the charge all is the same. We can divide by Q. Divide by Q both sides. So we cancel the Q. So we all divide by Q. So in the end, we get this formula. 1 over C total equal to 1 over C1 plus 1 over C2 plus 1 over C3. Yeah, so that's the formula, class, to find the effective capacitance. Is that correct, class? Let's check out. Yes, series capacitor is 1 over C. 1 over C. Yeah, I'm correct. Yeah. So, okay, why he put C effective? What does it mean by effective? Effective or equivalent capacitance. You see, they combine these three become one. We call it equivalent capacitance. So that means this whole thing. Let me. This whole thing. This three capacitor can be combined into one, which gives the same impact. They can combine into one, so they can become only one capacitor. You can use one capacitor to substitute all of them and give the same impact, give the same result. Okay. The one capacitor that are able to substitute all three is called effective capacitance, yeah, or equivalent capacitance. Yeah, we put it as C effective. This C effective can be written as C equivalent or C total lah. Yeah. So the effective, we call it effective or equivalent. 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 Yeah, it means total lah, the total capacitance. Okay. Yeah, effective equivalent. You use one capacitor to to substitute all three, which and give the same result. This is what we call equivalent capacitance. Yeah, setara, nilai capacitor yang setara. Satu capacitor yang setara kepada tiga. Like that. Yeah. Okay, so that's all. Understand? Yeah. So I continue to capacitor in parallel. Yeah, capacitor in parallel. Let's write down. Okay, let's write down this one. Okay. Now in parallel. Yeah, in parallel class. So what about parallel? Capacitor in parallel. Capacitor in parallel. So we learn about capacitor in parallel. Like this. This is parallel class. Parallel. That means it's like side by side combination. Side by side. Yeah. So we have capacitor 1, capacitor 2, capacitor 3. Okay. This one's the battery. Just put as a total voltage. Okay. So first thing, what do we know about this? Okay. So this is a capacitor in parallel. Okay. Let's look at the note first. Yeah, parallel capacitor in parallel. So capacitor in parallel becomes the charge is plus. Last time is voltage plus. This time it become opposite. The charge for capacitor in parallel, they plus, but voltage is the same. V total equal to V1 equal to V2 equal to V3. All the same voltage. Yeah, last time is voltage plus. This time is charge plus. Last time is Q equal. Now is V equal. Do you see the comparison, the difference between series and parallel? I hope that you remember. So effective capacitance is just C1 plus C2 plus C3. Okay, so how do we derive this formula? Okay, so we start with potential difference. Yeah, why is it equal? V1 equal to V2 equal to V3. Why? Why? Like this class. First of all, this battery is only the battery has positive, negative. All three capacitor is uncharged. Okay, this V total is let's say this V total is this V total is let's say 10 volt lah. I put also 10 volt. Sorry, 10 volt. Okay. So what about the voltage for each capacitor? In parallel. How? Okay, so it's like this. So if the voltage across battery is 10 volt, that means the negative terminal is 0 volt. The positive terminal is 10 volt. Okay, 0 volt and 10 volt. So all the negative, all this line over here, all 0 volt, all become 0 volt, 0 volt, 0 volt, 0 volt. All the line here 0 volt, all potential 0, and the one connected to the positive terminal all have the same potential, 10 volt, 10 volt, 10 volt, 10 volt. So I want to ask you, what is the voltage across C1, voltage across C2, voltage across C3? 10 minus 0, 10 minus 0, 10 minus 0. So it's also 10 volt, 10 volt, 10 volt. Isn't it, class? All of them have the same voltage. So that's why I say V total equal to V1 equal to V2 equal to V3, because parallel, if capacitor in parallel, they all share the same voltage because their leg both connected directly to the positive and negative terminal of battery. All of them, all their, let's say all their left leg, the left leg of C1, left leg of C2, left leg of C3 connect to the same 10 volt positive terminal. All the right leg of C1, right leg of C2, right leg of C3 all connect to the same negative terminal of 0 volt. So all of them have the same voltage. Compared to the series, only the left leg of C1 connect to the 10 volt, but the left leg of C2 not connect to the 10 volt, it connect to the capacitor C1. C3, the left leg connect to capacitor C2, not to the 10 volt. So all of them have this different voltage. Plus. If parallel, all the left leg of capacitor connect to the same positive terminal. That's why all of them have the same 10 volt. And the right leg all have the same potential, 0 volt. So turn out all have the same potential difference. V1 equal to V2 equal to V3. Understand, class? Understand? Good. So, how about charge, class? How about charge? Okay. I like to quote what you learned before in parallel resistor also, yeah? Parallel resistor. Remember you learned about parallel resistor? Okay, I should draw the resistor in parallel. So, yeah? Because I want to relate what? I want to relate between, now I want to talk about charge. I want to talk about charge. When talk about charge, I like to relate to resistor. Yeah, because charge is like current. Like rate of flow of charge. Current is rate of flow of charge actually. Okay, so charge is like current. So now we learn parallel capacitor. So I want to relate to parallel resistor. Let's draw parallel resistor. Parallel resistor. Okay, parallel resistor. Okay, so this is R1, R2, R3. What do you learn before, class? Remember you learned about current coming out from positive terminal. So this one is I total. I total moving in here. It's I total. I total coming from positive terminal and go to negative terminal. This I total break into, because this one got branches. You know, it's like, you know, this resistor is like, if we draw it the other way, it's something like this. Same thing, it's like this one also. Just a little bit different in the diagram, but it's the same thing. Isn't it, class? This R1, this R2, this R3. So we can imagine the current come from the positive terminal. This is the I total, you know, current total. Current go to the R1, R2, and R3. They break off into 3 branches. The current, the circuit break off into 3 branches. So do all branches have the same current? Do all branches have the same current? Or can I say all the branches current is the same current as I total? Is it correct? Can we say, oh, one current become I total here, I total here, I total here also. So that means I1 equal to I2 equal to I3 equal to I total. Is that make sense? No, because we talk about conservation of charge. Let's say like this current is let's say it's got 10 coulomb of charge flowing. 10 coulomb of charge flowing. So it's impossible to say, oh, 10 coulomb, yeah, 10 coulomb coming in, suddenly this charge become multiple. Oh, become the 10 coulomb also enter, 10 coulomb enter R1, 10 coulomb also enter R2, 10 coulomb also enter R3. Mana boleh 10 coulomb become 30 coulomb? How can 10 coulomb break off become 30 coulomb? How can, impossible lah kan, class. Impossible kan. It should be something like, current is a flow of charge. Yeah. I'm taking charge, charge. Current is like flow of charge. It's like water flowing in the drain. Water flowing in the drain. The water itself is a charge. When the water flowing in the drain is become current. Understand? So, impossible to say 10 coulomb become 30 coulomb. They are distributes equally. Cannot. It should be something like, 2 coulomb going to R1, and then got 3 coulomb goes to R2, and then the rest of 5 coulomb, 5 coulomb goes to R3, and then all these charge combine again, 2 coulomb, 3 coulomb, and 5 coulomb combine again become 10 coulomb, which is the I total. Isn't it, class? Isn't it that way? So all of them have this different current. Yeah, they should break off into 3 branches. Okay, class, this one is very easy. Yeah, shouldn't spend so much time. So what I can say is, okay. So what I can say is, they become put it as I1 here, I2 here, I3 here. So something like, I total equal to I1 plus I2. Am I recording? Yeah, I'm still recording. Yeah. Okay. I1 plus I2 plus I3. It should be plus plus plus. So saying this is like charge, So same goes to this thing. It should be also, charge equal to Q1 plus Q2 plus Q3. This one is like, charge is like current. Current is like charge. Current I. Understand? Charge is like current. So same lah. Resistor and parallel same. Okay. So or you can say, I take it another way to explain. Maybe I can say, of course I can say, let's say C1 is 1 farad, C2 is 2 farad, C3 is 3 farad. Do you still remember what's the meaning of capacitor? Still remember the meaning of capacitor? Capacitor is charge over voltage. Remember that? Charge over voltage. That means capacitor is the ability to store charge. Ability to store charge. So if let's say I say capacitor of 1 farad, like the first capacitor of 1 farad. What does it mean, class? It means for a 1 volt battery, if I connect the capacitor to 1 volt battery, I can store 1 coulomb of charge. 1 coulomb of charge for 1 volt battery. If capacitor 2, which is the 2 farad, what does it mean? It means I can store 2 coulomb for the same battery. Same battery 1 volt. I can store 2 coulomb instead of only 1 coulomb. I can store 2 coulomb if it is 2 farad. If 1 farad only can store 1 coulomb for the same battery 1 volt. If 2 farad, I can store more charge for the same battery 1 volt. If C3, oops, what is this? C3 is let's say 3 farad. What does it mean, class? It means I can store for the same battery 1 volt. I can store 3 coulomb because that means C3 is the biggest capacitor. it has the highest ability to store charge. It can store more charge. It can store the most charge among 3. It can store the most charge among 3 using the same battery 1 volt. It can store 3 coulomb. So imagine if you connect these 3 capacitor in parallel to the battery 10 volt, how much charge is stored in Q1? How much charge is stored in Q1? If 1 volt is 1 coulomb, how about 10 volt? Just use the formula Q equal to CV. Isn't it, class? Q equal to CV. If, like, for example, C1 is 1 farad. C1 is 1 farad. Let's calculate Q1. C1 is 1 farad. So, now your voltage is 10 volt. 10 volt. So it's 10 coulomb. So the first capacitor is the Q1. The Q1 is 10 coulomb. So how about Q2, class? How about Q2? Tell me. 2 farad multiply 10 volt also. How many charge can be stored in 2 farad? Tell me, class. 20 coulomb, isn't it, class? 20 coulomb, yeah? For the same battery, 10 volt, yeah? You write down in, I cannot see because I only have one screen. I cannot see, yeah? Your comment or what? C3, capacitor 3 can store more charge because 3 farad. So 3 multiply 10 volt, how many charge can be stored? 30 coulomb of charge can be stored, isn't it, class? Yeah. So all of them like connect to the same battery 10 volt, and because they all have different ability to store charge, C3 has the highest ability of all, so it stores the most charge. It stores the most charge. That means how? That means when you connect these 3 capacitors to the parallel to the voltage, it's like, you know, 30 coulomb of electron is attracted from the left plate, go to the battery. So that means got 30 coulomb, 30 coulomb is attracted, attracted from this plate. And then for C2 got 20 coulomb of charge is attracted. For C1 is only 10 coulomb of electron attracted. So total charge attracted from all capacitor is 30 plus 20 plus 10, which is equal to 60 coulomb of electron attracted to the positive plate. And then the negative plate give away 60 coulomb to deposit to the negative plate of each capacitor. So 30 coulomb go to the C3, and then 20 coulomb goes to C2, and then 10 coulomb goes to C1. Understand, class? So it's like distribution of charge according to the ability of capacitor to store charge. Okay? Ability. The more capacitance means more ability to store charge. So that's why it's different. That's why it's like, you know, Q1 plus Q2 plus Q3 equal to the Q total. 60 coulomb is the Q total. Understand? 60 coulomb is the Q total. Okay? Finish. Now, same thing like this current. Current I total equal to I1, I2, I3. Yeah? It's like, current is like charge, you know? Current is like charge. Charge flowing in the circuit. Now, we want to know the formula for capacitance. Yeah, what's the formula for capacitance? So start from this formula. Okay. So how? So it's like, you know, we use the formula Q equal to CV. Q equal to CV. So Q total equal to what? C total V total equal to Q1 is C1 V1. Q2 is C2 V2, and Q3 is C3 V3. Okay, but then the voltage is the same. Voltage all is the same. We can put all equal to V. So that means we can cancel out, divide. We divide voltage from left hand side and right hand side. When we divide voltage, divide by the, because all of them have the same voltage. When we divide by voltage, that means the voltage all cancel. So we become what? Become C total equal to C1 plus C2 plus C3. Yeah. So that's the formula for total capacitance for capacitor in parallel. C1 plus C2 plus C3. Proven. Proven. Okay, class? Understand? What does it mean by C total again? C total means we can combine. We can combine, we can combine all these three capacitor. We can combine all three, become one. Become one equivalent capacitor. Become one equivalent capacitor. That means we can use one capacitor to substitute all three. Become one. Yeah, all three become one. So this is C equivalent. This is C total is called the C equivalent. Normally don't write C total lah. Yeah, we write C equivalent, or we put it as C effective. Normally we don't write C total. We write C equivalent or C effective. That's the right way to write. Okay. So to find C equivalent is C1 plus C2 plus C3. So that's all for class for this one. Yeah, for capacitor in series and parallel. But for, remember, it's opposite compared to the resistor. If resistor for for capacitor we use Q equal to CV, but for resistor we use a formula V equal to IR to derive. Because of the difference in formula, this one capacitor use Q equal to CV, and resistor use V equal to IR. That's because of this one. That's why for resistor the total resistance has a different formula. For resistor in series, it become R total equal to R1 plus R2 plus R3. Yeah, because it use V equal to IR to derive. And then for resistor or parallel, okay, parallel, the voltage for this one, let me write it out everything. So for this one, the voltage is still the same, because parallel, parallel, all of them have the same voltage. But the total resistance or effective resistance is 1 over R for resistor. 1 over R1, 1 R1, 1 over R2, 1 over R3. Okay. Do you see the difference? Maybe I should also this one, and then again for this one. Yeah. Do you see the difference? Capacitor in series is 1 over C, but resistor in series is plus plus plus. But capacitor in parallel is plus plus plus, but resistor in parallel is 1 over R. So it's like opposite. Yeah, it's like opposite. The series become parallel, the parallel becomes series, like that. Yeah. Okay. Understand? So it's opposite lah. If capacitor in series use 1 over C, but for resistor the parallel one use 1 over R. Yeah. For capacitor in parallel they use C plus plus plus, but for that one is for series resistor, which is plus plus plus. So it's just opposite. But like I said, the charge is follow. Yeah, the charge follow the current. Yeah, equal. The voltage also, if parallel is plus plus, this one voltage plus plus. This parallel capacitor, the charge is plus together, the current is plus together. The voltage is equal for parallel. For resistor also voltage equal. That's the common. And that's all for I want to explain for today. Yeah. So how is the class? Yeah, how's the lesson class? Yeah, do you understand?
Understand, sir.
Yeah, good. So I will post this video in the YouTube. Yeah, now. Okay, thank you for your time today. So the question I will discuss in the tutorial lah. Okay, not enough time to discuss now. Okay. Actually, I also got another following video about charging and discharging capacitor. I made for Saturday for class F13. They are faster. So you can also look up the video also. Yeah, look at the video before I teach in the class. Yeah. Hopefully you can watch the video first because it's a very detailed video. I explain about charging and discharging capacitor. Yeah, in a very detailed way. I explain it. Yeah? So hope you watch the video first. Yeah. I also already shared in the Telegram group. Yeah, for the video. I already shared. Just look up the video. Okay, thank you for your time. Bye.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.
Thank you, sir.
Okay.
Thank you, sir.
Yeah, thank you.
Thank you,
Welcome.
sir.
Yeah.